Hello and welcome to another episode of the CG Garage. This is episode number 483 featuring Erick Geisler, who is the CTO of Global Objects. Erick is one of those guys who I probably should have known for the last 20 years. We are definitely know the same people. We've been around the same circle of friends for a long time, but for some reason, I never actually met him in person or met him at all until this year. I met him at the VES Awards. He was introduced to me by a good friend, Darren Ross, and we've been in contact ever since. We've been hanging out and doing a bunch of interesting things together, but he's been really a great kind of guy. He's been in the industry for a long, long time. He actually started off as a child actor, and became more interested in things that were happening behind the camera that are instead of in front of the camera. He ended up going to Art Center for school and started a bunch of different companies. And he worked on lots of great movies and movies like Independence Day, Titanic, Day After Tomorrow. Really, really cool. He's currently at a new company called Global Object, which is where he works as the CTO of that company. And they are doing some very interesting work in terms of creating large data sets of hyper accurate, hyper detailed objects that they scan, objects and environments, etc. So they're creating this big library of assets that are being used for many different purposes. And we talk a little bit about that. We talk about how it's being used for things like virtual production, as well as AI training and all kinds of different things. So really interesting work that he's doing over at Global Objects. Obviously, because they're doing that, we're also talked a lot about USD and MaterialX, different standards that people are doing, and real-time. Real-time rendering is a big part of it, which is one of the things that we've been dealing with them as well. It's sort of really kind of interesting to talk to Erick all about that stuff. So very cool to do that. Okay, speaking of real-time, I want to let you know that Vantage 2 Update 5 is out. Let you guys know that a couple times, but it's really, really cool. They've added a bunch of new things, including VR support via OpenXR, animated vegetations that is now through our Cosmos library. We've added those things, which is really cool, that are native inside of Vantage, and rounded corner support, and also ACES CG support as well. So really cool. If you guys want to know more about Vantage, Vantage is our real-time ray tracing solution that works in conjunction with V-Ray, as well as Corona, which I'm about to talk to you guys about as well. Corona 12 is also out, and like I just mentioned, it also allows you to export directly to Vantage. So if you have a Corona scene that you've created, you'll be able to export that to Vantage and experience that in real-time ray tracing, which is really, really cool. Corona 12 also has scattered incident brushes, curved decals, and there's a new virtual frame buffer 2, which includes Corona EXR or CXR files that are going to go straight to editing in your Corona image editor. So lots of cool stuff happening in Corona 12. Of course, if you want to know more about this, just go to chaos.com for all of our product news, including the Vantage 2 Update 5 and Corona 12. We have a couple of events that are going on that are going to happen very soon. You can find all of this over at chaos.com/events. The D2 conference is happening at the end of August. Very exciting. I love the D2 conference. It's happening in Vienna, as it does every year. It is one of the premier ArcViz events that happens every year. And it's happening August 29th through the 31st. Really, really cool stuff. D2 over in Vienna. Also want to mention that the Rainbow Conference is happening on September 5th through the 6th in London, and we will be there. I will not be there, but I do want to mention that there is going to be a showing, a very early sneak showing of a short film that I had been working on out of the Chaos Innovation Lab, and part of collaboration with Martini Giant Production that we've been doing. A short that involves Project Arena, which is our real-time solution for virtual production that we've been working on along with Vantage. And the short itself is been a big deal, actually. Something I've been working on for a long time. A lot of fun creatively to do this short with some really interesting things. So if you happen to be in London and you'd like to do that, make sure and register. It's going to be at the Rainbow Conference. Again, September 5th through the 6th. Again, go to chaos.com/events for all of those event news. as well. So if you guys want to know more about the podcast, you guys know where the podcast page is. It is at chaos.com/CG Garage. If you'd like to follow us on Facebook, just go to facebook.com/CG Garage Podcast. If you'd like to watch this podcast, this is actually a part of the podcast where Erick is doing a share screen to show us some of the stuff he's doing over at Global Objects. You guys can check it out on our YouTube channel. YouTube.com/Chaos Group TV is where we post all our videos, including the podcast itself. If you'd like to make any suggestions of podcasts or you'd like to give us some feedback, don't forget to email us, labs@chaos.com. Again, that is labs@chaos.com. But for now, please enjoy episode number 483 with Erick Geisler.
Welcome to another CG Garage, where the Chaos Group talks. You'll know it's over when the last bucket drops. We're gonna fire off rays in high dynamic range. We know that ambient occlusion is passe. Global illumination won't lead you astray. And while image-based lighting is really swell, you need to make sure everything has Fresnel.
You and I have a feeling like we should have known each other way longer.
Yeah.
Like
It
we've been
makes
doing
sense.
this. Yeah, it's like, wait a minute, how do I not know you?
We know all the same people. We go in all the same circles. It's been
I
kind
know.
of crazy.
It's kind of funny. But let's start about that. I mean, like, okay, so what got you into CG and computer graphics and visual effects? Like, what was the thing that sort of got this whole train going for you?
Well, it was funny because like when I started, I always was loved art. Like I was always an art kid.
Okay.
And
where was this?
So this was here in Los Angeles. So I grew up mostly, I was born in Detroit.
Right.
In the 70s. And then we moved around a little bit. And then my parents settled. Finally, they came to Los Angeles in around 1980. And, I was just always into the art scene, comics, that sort of thing. It was really, very inspirational for me. And then I started working, as a young teenager, I had done acting. Some of my friends were actors, just bit parts. I was on Who's the Boss, Growing Pains, My Two Dads, just little one-liner sort of things. And as an actor, you get incredibly bored, right? Waiting for everything to happen. And so I started picking all of the camera guys' brains and all these other people. And I sort of just fell in love with filmmaking.
Wow.
So I'm an art nerd. I fall in love with filmmaking, and I go to school for illustration design. I went to Art Center in Pasadena. And they had an incredible computer graphics curriculum. And I, one day a buddy of mine was doing something on a big SGI computer in the computer graphics lab. And I sat down and I was just like, oh my God, I can create all of the things that I want to create. And it was still rudimentary, but it was enough of a glimpse to get the bug that bit me, basically. And
was Alex Alvarez there when you were there?
Yeah, Alex was there. Aaron Crumweedy was working. I met him on the Alias side of things back in the day.
Right.
I had a little bit of a taste of it. So I had an apprenticeship. I went to a boarding school up in Oregon. And I had an apprenticeship at this place called True Vistas. And they were like an animation house. And they had done a lot of, it looked like it was computer graphics, but it really was a lot of process camera stuff, animation with backlit cells and things like that. And back in the 80s, there was the CBS Movie of the Week logos that would come in and stuff. And I was like, oh, this is so cool. So I got this little apprenticeship there, and once a week I would go there, and they got this Cubicomp computer. It was this really old, and nobody knew how to use it. So I just started burning through the manual, and next thing I knew, I was probably the most proficient person. And I'm a teenager, right? So they're like, what, how's it? So I had some computer graphics experience prior to finding the computer graphics lab at Art Center, and then it was just anywhere I could, get time on a workstation to sort of figure out.
Yeah, because back then it was just like an SGI. You don't buy those at your local radio
Oh,
station. Right?
it's like, yeah, it was like hundreds of thousands of dollars of hardware with hundreds of thousands of dollars of software, and
Right.
it wasn't readily available at all. It was incredibly expensive. So you would have to find, excuses or reasons to get onto this stuff. And so anywhere I could, I would just, park my butt in a chair and play with the early days of Alias, and Wavefront. Before it was Alias Wavefront, there were two different pieces of software.
Yep.
Softimage was pretty up there. And then, I would get jobs wherever I could, doing architectural visualization, commercial work. I met a guy, his name was Mitch. He was like a director, and he worked at Able. And so he worked for Robert Able, and they were working on like Cray computers and all this stuff. And he turned me on to his friends Brad DeGraff and Mike Warman, and they were doing some of the early computer graphics stuff. So I got into this club of guys because SGIs were so expensive. There was another sort of computer system called Symbolics. I don't know if you remember that, but
I don't, and I know a lot, but that's
So look
obscure,
up Symbolics. So Symbolics was this sort of like hardware. It had like a frame buffer. It did like 3D. It did like 2D. It was like this really interesting sort of computer system. And they had their own proprietary hardware and software all in one. And it had like a big Wacom tablet thing that you would use. So I worked on that for a little while. And right about, this is like early 90s, I want to say, is where there was like a change in the industry. And a buddy of mine showed me Electric Image. And I was like, oh, and this was on a Mac. And I'm like, holy shit, this is very revolutionary. And that was sort of the first time that
because it was a desktop computer, a regular, not.
Right.
Yeah.
It was a Mac 2FX with like 8 gigs of RAM. And it had like a True Vision graphics card in it. And it was
couldn't have been 8 gigs because that was a lot back then.
No,
are you sure it wasn't 2 gigs?
Maybe 8. Yeah, maybe it's 2 gigs of RAM. It wasn't a lot. It was like No, it wasn't 8 gigs. It was probably
because today people use 8 gigs, and that's
no, I'm wrong. I'm wrong. It was like no, there was a one. I remember we got a 1 gig hard drive, and it was like this big.
Yes.
So it must have been like 8K of RAM or something ridiculously small.
Yep. Probably 64K or something. Yeah.
Yeah, it was the Mac 2FX. It was like the first time the FX series had come into play, and they were using Electric Image on it. And then there was a modeler that was called Form Z. And so I was using Form Z to model and Electric Image to sort of do animation. And that lasted for quite a while. And then I met a lot of people in the Electric Image community. I got a little bit into the Lightwave world. So I kind of, it's like once you understood these early systems, they were all kind of the same, And then from there, I got, then I was back into Alias. So the Alias are now at this point, Alias is now running on SGIs that are smaller, like the Indigos and the desktop SGIs. Still very pricey.
Yes.
And, there was various visual effects companies, Metrolight, the Post Group, you would just go work. I learned compositing early on, discrete logic, Flame, back in the day. And there was a compositing software called Matador by Parallax Software.
I remember Matador. Yeah.
So I was, I would freelance, and I would work like at CIS and, Metrolight and all these different companies around Hollywood. And eventually, I got back. It was funny. You would bounce between the desktop systems that you could have at home and these more expensive systems that you could get paid for. And it went back and forth for a while. And then I went, I was using 3D Studio Max on a Windows PC. That was pretty revolutionary. I remember that Soft Image sort of made the bridge over to PC.
Yeah, Microsoft bought them.
That's right. And then that product totally died.
Well, they sold it to Avid, right? Or something like that.
That's exactly what happened. That's right. They sold it to Avid, and then Mental Ray got sold off, I guess, to NVIDIA back in the day, right? Yeah. And so I've been around this entire, this whole ecosystem for way too long. And I've seen all the changes and pitfalls but, always been in love with computer graphics. And then I started, when I got into Max, that was like, just post the Yoast sort of days, you know what I mean?
Right. So just when Autodesk acquired them.
Yeah, 3D Studio DOS, and then it went into like 3D Studio Max. That was like the first version.
Yep. I had Gary Yoast on this podcast, by the way.
Oh, really? Amazing. The father of 3ds Max. It's crazy. So I'd used that for a while, and then the subject of like external renderers started to like happen, and I was using Max pretty heavily, and then I got into I was trying to use it with Mental Ray or trying to use it with RenderMan.
RenderMan was not the connection with Max. It was mostly Maya at that point.
There was a RenderMan connection. You could do RenderMan on Max. It was very, very difficult, but there was like some scripts and stuff to kick out a rib file. But then there came along Brazil, right? And Brazil was just so easy. And Scott and Steve were just cranking this stuff out over at Blur. Yep. They were making it available for people to use. And I was using that for a while. And it was the first time we were, it was like global illumination and all these, advanced rendering techniques were sort of, available to us common folk.
Yeah, it was kind of a big deal because, this was around 2001-ish. Right?
Yeah.
2001, 2002. And then that was when, V-Ray and Brazil and Final Render kind of came into the scene. And it was kind of like the big visual effects companies like, what do you mean it's not RenderMan? Like it was a big deal. Yeah.
It was a huge deal. And I remember sort of like the like the big turning point was it Stealth? What movie? Yeah, it was on Stealth. And I remember Rob Niederhorst talking about how this one kid, Rene, who had done
this Spawn Rune showed the video of the fighter jet.
Yeah, and it
that he did in Sweden.
It was just blew away anything DD was doing at the time. It was like,
well, it was kind of embarrassing, right? That was a big moment, and it's kind of an important thing that happened. Was Rob Niederhorst? Rob Niederhorst has always been a very controversial person in the visual effects industry, which is why I love him, because he's always going to be
he's a disruptor. He's a complete disruptor.
He's a disruptor. He loves it. If something's disruptive, he's like, I'm going to go there until something happens. And so on Stealth, they had a huge skunkwork group because, Rob Cohen had just finished XXX. He was starting to get really popular, and he was going to do, he did Fast and Furious as well. And that was the first Fast and Furious, right? Which turned into obviously a huge franchise. But then he was like, I'm going to do this movie Stealth, and it's going to be big. And so it was like, they signed a whole skunkwork group of people to like look into making jets. And it was a lot of people, and they were working on it a long time. It never really looked right. And then this guy from Sweden did this video of a jet using Max in Brazil and just embarrassed everyone.
Just spanked.
And it looked perfect.
Yeah, spanked everybody completely.
Yeah. And they did a test, which, by the way, render tests are bullshit, but they did this render test, and I can explain why I think it's bullshit, but they did this render test, and they were like, okay, we're going to use RenderMan, Lightwave, V-Ray, and Brazil, right, to showcase how this is going to look. And by far, Brazil and V-Ray came out on top, right? But they decided to go with RenderMan because they couldn't find enough Max artists to work on.
Oh yeah,
and
no,
they didn't want to change their whole pipeline.
Well, I had lunch with Rob, so I had started a company called Red Engine Productions with John Chalfant. And this
I know John, of course.
Right.
Yes.
So
yes.
John and I started this production. So it was right after, this was right after Volker.
Day After Tomorrow.
Volker, and Mark had sort of closed the shop, and they're like, "We're selling everything. You guys interested?" And John and I were like, "Want to start a company?" We're like, "Yeah, why not? What the heck?" And it was really just a small, it was a small little place. It was over by the airport. And we were having lunch with Rob, and I had used Brazil a lot. And he was like, you want to come work on Stealth? I was like, I just started a company. I can't, but it was the first time he's like, we're doing this test with all these different renders. And I'm like, well, tell me a little bit more about V-Ray. He was really like, you really need to look into V-Ray. That was the first person to introduce me to V-Ray was Rob. And he was like, you really need to look.
Yeah.
I
introduced it to him.
Interesting. Wow. This is so full circle, right? So
and it was funny because Rob and I were both talking about this, there's gotta be a better way than ray tracing. It's gotta be the better way, right?
Right.
We can't keep doing this random thing. And then I went to, and this is and Darren Grant will probably attest to this. I went to Darren Grant and I told him, I was like, why are we doing this bullshit ambient occlusion pipeline for RenderMan when we can just ray trace it and it'll be done with it, right? And he's looked at me, he's like, do you really think that Digital Domain is going to give up their relationship or give up RenderMan, a well-established renderer, for a renderer written by two guys from Bulgaria?
Right? And
he's right. He's not wrong for saying that.
No, but
at the same time.
But you're touching on the part of the whole politics of everything, because it wasn't necessarily the best tool. And I understood how these big VFX companies, it's a hard wheel to turn. It's like.
Yeah, it's like stirring the Exxon Valdez,
Yeah, it's not easy, and that's why that's what John and I were doing. Like we would filmmakers would come to us and try stuff out prior to going to a big VFX house, and this was in the days when we would work with Cameron, and we would work with the Wachowski brothers, and we would work with we would do small little projects to just sort of test things, and then they would take those things to the bigger companies for the execution.
Right.
And that's what, sort of what John and I were doing, is we were sort of like a skunk works for filmmakers, because we were good. We were good. John was a really good designer, and I knew film and cameras and stuff and VFX. So it kind of made sense for a while. So,
and you were close with Brandon Davis too, I'm sure.
Oh yeah, no. Well, Brandon lived with John, right, forever.
Yeah,
but he wasn't disappearing off to go, hunt Osama bin Laden or whatever.
Right.
And he was like,
he did that while we were at DD. He would basically he would disappear for a few months, and I'm like, "Where'd you go?" It's like, I can't tell you where I went, but I can tell you that my Korean has gotten a lot better.
Just know that he was so good at the part, he knew particles better than anybody.
Oh yeah,
in the universe. So they were living together, and so and that was how I got introduced to V-Ray, and it was just like this. Everything just sort of made sense, and I love Scott and Steve, and I loved Brazil, but it wasn't very buttoned up. You know what I mean? It had a lot of. There were just a lot of things that, they had done a lot, but V-Rays are, what I loved, and still love about Vlado is he will spend the time to do it right. You know what I mean? He'll spend the time to put in the feature set. He'll spend the time to really understand what you need as an artist and how he can help you. And that just translated in this incredible renderer that was everything you could ever want and more. And I had used, do you know Riff Dagger at all?
Yeah.
So Riff was always a Final Render guy. He's like Final Render, and I'm not bagging Final Render or or and I love those, Edwin's a friend, but like,
Sure.
there was always like, I don't know. I gravitated towards Brazil. I mean, I gravitated towards V-Ray because it was so much easier than these other renderers, and
Right.
the quality I was able to get and the speed I was able to get that quality made sense and made a difference for me. And that's how I found it. Rob turned me onto it. I started playing with it and using it, and lo and behold, it sort of changed, the way I worked as an artist in rendering forever, after that. And because I was a Max person, it was so easy because it was fully integrated, from day one.
Yep. Yeah. It's interesting because, in the end, like those were big days, right? Like there was Final Render in Brazil and V-Ray and Max, and then Disruption and Mental Ray and RenderMan were like the big boys, and it's all about disruption. And it was very, from the user point of view, it was almost a religion in terms of what renderer you're using.
Oh, it was.
And
more like a cult, actually, more of a cult.
Yeah. More of a cult, but those guys have unbelievable respect for each other. It's really interesting. So just listening to, because I've been talking to Scott Kerman as well. He's doing great, by the way. He's back in visual effects, and I've been talking to him, and he's like, "Oh yeah, it's like in the end, I have massive respect for Vlado and all that stuff, And I said when we were starting to close down Brazil, which was called Splutterfish, I guess was the name of the company.
Splutterfish, that's right. That was their company. And Connie was like
the
tech support. Like you would call and Connie would be like, "Hello."
Yeah, pretty much. But it was like, it's like I wrote Chess Sullivan. It's like, well, just use V-Ray. It's like, that's what you, so it was very interesting to sort of see the mutual respect that all those guys had for each other back then.
And they were all doing some incredible stuff.
Mm-hmm.
It was, and you're right. The renderer was like, "Oh, you use this renderer. Oh, you use," and there were reasons, and there were like factions of people that were, and it was almost like this really healthy competition that was really bringing the rendering quality of everything up, all kind of at the same time, because you would have these research papers in rendering that would be happening. And then artists would see this and they'd be like, "Hey, I want that." And then they would be putting in these features, and then we would be trying it. And it was this really...
It was the ray tracing revolution from back then, right? Because at that point, still, people were still using rasterized rendering or a hybrid version of it. And then people who'd come in, it's like, just do full ray tracing. And to them, there's like, that's impossible. You can't do that. And then you're like, prove them wrong. Doing it on a freaking, homemade computer, you were doing better renderings of an airplane than anyone else. And it was like, it just basically is just a big FU to the industry who had spent, $100,000 per user for hardware and software.
Yeah,
right.
Easily. And then it was, and those are hardships to turn. And it was these 2-man teams or 3-man, artist teams, or these small guys who needed, what was their edge, and their edge was the ability to try different stuff and
right.
And break out, render passes and do all this, crazy comp, things. And a lot of what we were doing as an artist was trying to catch up to the fact that we couldn't ray trace. You know what I mean? It was all this cheating going on for so long. I remember all these different...
Here we are again, by the way, in the real-time world doing the same thing.
Stuff. It's exactly the same thing. It's like, all these bucket of cheats that you learn so well because you're trying to save all this time and energy, and again, and these tools come along that just are a revolution, and it really was a revolution. And I remember how it started to permeate through DD after that, and how their car commercials and everything started, and all my friends were like, "I just got a job in the DD commercial." It was always in the commercial department,
Yeah.
Because back in the day,
that was Ed Olbrich and Eric Barba were the big guys who were basically promoting.
That was right. It was Ed and Eric, and they had their little sort of skunk works of their own, and they were doing Benjamin Buttons. And
that's exactly right.
Back with the Lightwave guys, Rusty Ippolito, and all that whole group of guys.
They did it with Mental Ray, but it was still like they were like, no, in order to do proper phases, you need to ray trace it, and that just seemed like crazy to people, right?
Yeah, they were like, "What are you talking about?" And then
Mm-hmm.
I remember, so I was working at Larry Levinson Productions, which was
Uh-huh.
LLP is what everybody called it, and we had this boutique visual effects house inside of that production company. We were doing like 30 plus movies a year, just cranking out, tons and tons and tons of work. And, you know, it was the same problem there. My boss was a guy named Ron Sabatino. Ron had built up Square Soft and worked
Oh,
on
right.
Final Fantasy, right?
That was in Hawaii, right?
Yeah, in Honolulu.
Yeah.
They had done the first Final Fantasy, which was kudos to them. I mean, it looked terrifying, but kudos to them. You know what I mean? Somebody
It flopped, but it was kind of revolutionary.
it was like there are these revolutionary points inside of
Yes.
CG and VFX where it's like the first guy through the door gets shot, but if he didn't open the door, no one else would have gone through it. You know what I mean?
Right.
Like Pixar with their first, with Toy Story, it was like the first, animated feature ever done in CG, and it was so revolutionary at the time.
Yep.
And all of this, it's an interesting industry. But even there, they were like, "Oh no, we need to be mental ray for 3D," and I'm like, "Nope, not a chance." Like I'm not going through this again. I went through this, I know how difficult. Now I'm going to need some engineering support. Now I'm going to need some, do you really want to do that? And they were dead set on it. And I remember Andy Copra. Remember Andy? So Andy worked at Mental Ray, and he came in and he did they installed a bunch of Mental Ray, and I don't think we used it.
Really?
Yeah, because I was running the CG department there. So it was like,
okay.
I was like, yeah, you can install it, and I'm sure it's cool, but I don't think we're going to use it. And we were using, these alternative tools, and it just it's tough, but it changed the industry forever. So now all of the all renderers have to support all the stuff that it's always supported, and
right.
Watching that whole evolution of pretend rendering, trying to get to the ray trace. I'll never forget the Pepe Land thing that came out with the Arnold renderer.
Yeah, Arnold.
That there was like a little clip that was moving around the internet, and it was just so realistic. It was like, that's what we've been looking for, You got to remember, when I started in computer graphics, we didn't even have shadows. Like that was like for a while. So
yes.
And now, ray tracing and bounces and subsurface scattering and PBR materials, and we've come so far in such a short span of time.
What are your thoughts about like the push of the visual effects industry to sort of push for things like USD and MaterialX? Do you think that sort of it enables people to use whatever the hell they want, and then they don't have to talk about what render they're using?
Yeah, I mean, I think
they can use what they want.
I think a standardization is definitely needed. The problem is that even today we're still plagued with the same problems that we've been plagued with for years and years and years and years, which is we don't really have a standardization for what we do, right? There's a million ways to skin the cat. There's a million dials to turn to get something to look a certain way. With MaterialX and USD, I look at them as kind of like mastering formats. Like if you're going to model something and you want it to live in a mastering, like a master format, those are really good mastering formats that are really allow you to use it in any render in a way that it's going to behave the right way when you put physically based lighting and things around it. That's what's important. Like I think we're all now to the point where we know we need physically based lighting, and it needs to react the same way on the things that we're putting together. And that's what USD and MaterialX sort of is the hope for. And I think I'm hoping that it's right. There's problems with USD, there's so many ways of packing a USD. It's really a container and not a format necessarily.
Right.
And MaterialX is good, but it's not really adopted enough yet. So, but it's a good start.
Yeah. Sure. Okay. Well, we'll get back to that, but after LLP, what was going on after that?
Yeah. So after LLP, I started that Red Engine Productions with John Chalfant. Mm-hmm. And then we ended up selling that company to another company called HTV Illuminate. And one of the things that we were doing, Red Engine had another company called Red Lux, and we were building film scanning machines, basically. And they were in the dailies business. They really wanted to do higher end scanning and capture, and they wanted us to build a scanner that could do IMAX and 65 millimeter and other stuff, because their bread and butter was dailies and restoration work.
Okay.
And they wanted to also build the visual effects unit. So I was there. I ended up becoming the vice president of creative services. It probably wasn't the right move for us, but we sold the company. John went off and started making his own films and stuff. I lasted there maybe a year. It was a corporate gig, and they were doing dailies, and it was as cool as all of that stuff was. It really, my heart was in CG and VFX and stuff, and they weren't really doing a lot of it. So, I talked to the owners of the company. I'm like, guys, it would really be great if I could get out of this contract, and I want to open up another boutique visual effects company. I'm going to do it here. In the same, we're over on Cahuenga West, in the glass building that's over by the freeway there. And I'm like, I'll open one up here. It's close by where I live. And so I started what then became G2 Immersive Studios. And that was the genesis of that, basically.
Okay.
And then we started working on television. So I was doing a show called Sports Science. And that was an ESPN show that had lots and lots of like sports visuals and stuff. We ended up getting nominated 7 times for an Emmy. I won 2 times for being the creative director of the show. And then did G2 for many, many years after that. Then after that, I opened up another sort of production services / visual effects company with my wife called Shiloh Media Group. And then that's when we were doing that production started to sort of halt last year. And we were like, what do we want to do? And we really were thinking about, we were getting into virtual production pretty heavy. People were contracting us to sort of build these real time, we started getting into real time construction. And we started, Global Objects, which is our company today. And the reason we started was because there really wasn't a database of really high-end photorealistic 3D CGI. It just doesn't really.
Yeah, explain to people what is Global Objects and what's the idea behind it.
Yeah, so as a company, we're building digital twins, right? So and we're building it in the highest quality digital twins, highest quality photorealistic assets that we can produce. And so we really sort of went back to the drawing board and was like, okay, let's just investigate where we're at in 3D, where we're at in real time, where we're at in all of this, and let's figure out what the best way is to start capturing data and objects, locations, props, sets, etc., and faithfully reproduce them, using PBR materials and ray tracing and real time and all this other stuff. So we raised a seed round. We were fortunate enough to get a family office that was very interested in this as the future. We knew that betting on 3D now is probably a good time, because with all that's going on with machine learning, the problem is that most of machine vision and machine learning, most of the training sets and things that have been trained on has been trained on like a single eye, right? Monocular, 2D image. Most of the data and training for machine learning is 2D. We knew that, we see with two eyes, right? And so there aren't really high quality data sets based on the real world of 3-dimensional data. And that breaks down to, shaders that are physically based, capture that has captured finite details of things. And so our bet and the bet of the company is that it's going to be needed. The high quality data is going to be needed. And so we're building a very large catalog of data, and then we're training machines on how to replicate that data photorealistically.
Interesting. So you make the CG for it to make CG.
Right. Step one was how do we make photorealistic CG capture? Like, how do we capture something and faithfully reproduce it, right? And that was tough because it was like, okay, photogrammetry is great, but it doesn't do much for your shaders, right? You don't get the shader tree, right? And then it's like, okay, so how do we solve that? Well, you have to look at the photometrics, right? It's like, okay. And photogrammetry doesn't solve everything. It's not good with translucent materials, glass, and shiny things. So you have to look at laser scanning. And then it's like, okay, laser scanning doesn't pick up any color data. So we spent a year in quite a chunk of change just testing and doing a bunch of R&D to sort of figure out, okay, what are the best approaches, and it really ended up being a combination of a bunch of different things that ended up in us, developing our scanners. That we have some proprietary scanners now, and they do acquire objects and locations, and they're very, very accurate. And the stuff looks, we can put it next to a photograph of something, and most people will have a very hard time discerning the difference between the two, because we're really trying to capture every essence of the detail of it.
What are your thoughts about, obviously you were talking about acquiring 3D data and that, photogrammetry has its downfalls. But now there's been a lot of this talk about NeRFs and Gaussian Splats. Like, what are your thoughts about that?
Those are cool. Radiance fields are amazing. But the problem with the radiance field is it's a radiance field. You can't really alter it very easily, right? You can't change the sun on a radiance field, right? You can't relight it very easily and get something that behaves right. So it's a nice medium for, I think radiance fields and NeRFs are really nice mediums for distribution of something, like is a cool way to look at a 3D scene. But it's not really a mastering format, right? It's not really a way to capture something and preserve it so that it works under any lighting condition, right? And that's where I do believe that we will be using them, and we definitely have a small group of guys here that are working on, taking our data sets and spitting out, splats and NeRFs and all that stuff. But it's mostly for how do we, deliver this out to a stage, or how do we, it's also good at certain things. It's for cheating. Again, it's really good with like grass and high frequency detail leaves, but it's much better if you can just throw a trillion leaves at something. You know what I mean? It's like, that looks
which we can.
better. That thing you showed me, I was like, whoa, that's cool.
Yeah, I know what you mean. But this is kind of an interesting thing. Like, you're talking about mastering again, right? Like how, and this comes back to what we were saying about USD. Everyone is looking for that one format that I say, okay, this is the format that if I'm going to collect 3D data on the internet, that's what it's going to be.
Right.
So the I don't want to say JPEG, maybe EXR, right? What is the EXR of 3D data?
What is the EXR of 3D data? And I can show you one of our first scans where we're like, oh, wow, okay, we're getting somewhere. I can share my screen in this thing, right?
I think you can. Yeah. They'll have to have Henry figure out how to put this all together.
Yeah. See if he can figure out, but I want to show you,
Sure.
let's see, scans.
So yeah, if you're listening to this, you're probably not going to see it, but we'll describe what we see.
Yeah. If you're listening,
and you should watch the YouTube.
You may not be able to see what we're about to show you. But maybe
if you want to see it, pull over your car while you're driving.
Yeah, don't. So it was funny. We were like trying to figure out, racking our heads, trying to figure out how do we really get all of the data from a scan, because you can't scale. It's hard to scale artists, right? Because the good artists, there just isn't enough good artists who are incredibly photorealistic. CG is hard to do if the parameters aren't tight enough. Let's just put it that way.
Sure.
If the parameters are tight enough, then you can get there, but it has been really tough. I'm trying not to crash my computer. I have so many things open. Hold on one second.
Yeah, I know what you mean. Like, I always love the simpler solutions to get there faster.
Yeah. So this.
Okay.
So this was,
this is a shoe we're looking at.
We're just looking at a boot. It's like a construction boot.
Okay.
Right? Yeah. But like all of these like little scratches and bumps and details here.
Yeah.
Something we really were trying to preserve with all the data points. So like, if you're looking at the normals, right? Look at all the micro surface details here. Right?
Yep.
And then you look at the albedo maps, right? And then the roughness data. Being able to get roughness is really important, because there are like areas here where we transition from leather to like metal, and then the rivets here where they transition from leather to metal. It's like that. That stuff is really hard to capture with a scan. And so by combining, and you want to do it in a way that it's going to faithfully reproduce that data set. And so the geometry is not very, there's like, I don't know, there's like 100,000 polygons here, but the work that's being done is being done here in the shader, right? So you can see like where the split is here, and how it behaves differently. And so that's the type of detail and the things that we're looking at, the stitching detail and all of this sort of thing, the shoelaces and how to, the mud that's on the top of the shoe, and how to like accurately.
Yeah. It's two different kind of things. Yeah.
Right. And so how do you capture that? And that was what we were trying to, that was the first aha moment for us. We were like, oh, this really is doable, especially if we take all these different modalities of like photometrics and photogrammetry and laser, and you sort of start meshing all this stuff together. It's a lot of data. There's like probably like 5,000 or 6,000 photographs that make up that data set, plus a laser scan. Right? Sure. And all that's got to be correlated and aligned and registered, and there's a lot of. But
isn't that the point of besides? I mean, I remember back in the early days, but I sound old. I remember the light fields, right? Light fields did require a bazillion photographs, but it seemed like so much redundant data. And that was the magic of NeRFs, is it could do everything that a light field could do with way less data points.
Way less.
And interpret. Do you interpret that through AI? Like, how do you get all the data?
That's where we're going with it. Like, once we have enough of this ground truth data, because it really isn't. If you go out there and you go, it's like, Chris, give me a library of photorealistic, consistently photorealistic objects. You're going to be like, I can cherry pick some things from Turbo Squid, and I can go over. There isn't like, so that we realized early on, we're going to have to build this ourselves just to have consistency.
But that is this thing that's sort of fascinating. I don't think people realize in order to train a lot of these AIs, you need a lot of data, and there is a huge market for people creating synthetic data to train AIs.
Right. Massive. It's massive. And the reason why it's huge is because studios right now are terrified because they don't know and some like OpenAI, they don't even know all of the things that they've trained some of their things on, right? And so having provenance of training is going to be really important in the future, especially when you're getting to institutional levels of using these tools. And again, they're tools. It's the same thing as it's a force multiplier for an artist, right? It's like, yes, it's going to take some jobs, but we used to have elevator people that used to take us from floor to floor, and now we don't, right? It's the same kind of a thing. It's just an evolution. And it's not, I don't think it'll ever replace you still will need people to drive this stuff. I tell people, I said, AI is not taking your job. It's the person that knows how to use it.
It's going to change your job.
Right? Yeah. It's going to change the job.
I mean, I remember, go back to V-Ray, for example, right? I remember back in let's say around 2006, 7, whatever. And then V-Ray started to change because there was too many parameters, right? And so Vlado started to do things where it's like, okay, I'm going to remove the need for you to mess with all these parameters by having having V-Ray be smarter, and it does all this other stuff. People were getting upset that he was doing that, saying, "I know V-Ray better." It's like, V-Ray better than Vlado.
Yeah, I don't think so.
And so, well, not just Vlado. Obviously, I know there's a lot more developers, but it was just philosophically, it was something that was definitely from from Vlado's point of view, is it had the developers sort of move away from it, where V-Ray could make those choices and those parameters became pointless. But there were people that literally said, my livelihood in the industry is knowing what dial to put into a render. I was like, that's a little sad.
I mean, you guys know what, you guys know that, it's all about iteration, right? It's all about from the time I make a decision to change a parameter to when I can see that result back. Like that's
how fast that is.
Yeah. That's it. Right. And I think, AI came on hot and heavy last year. It was all about generativeness, right? And now it's really all about, how do we control this thing? How are we getting control? Like, we're trying to figure out how to control it. And it kind of is like the early days of rendering, where you're just like, there's a billion parameters and you're just tweaking little things and doing little tests and trying to figure out, how do I control this thing? And so that's sort of the early days of this generative AI stuff reminds me so much of the early days of rendering. It's like, and rendering is interesting because, we have machine vision rendering, and then we have neural rendering, and those things are going to be like crossing the chasm soon too, where it's like, you're implying, I'm already doing stuff for like control nets where I've got I'll take a humanistic figure, I'll pose him the way that I want him to be posed, and I'll just pipe a Z buffer into a control net and use that to generate the position of my character in Stable Diffusion. So there's a lot of hybrid things that I think we're going to start to see in the world of rendering. That's going to be very interesting, especially in the next couple of years, as we seek to control this black box that everybody's looking at, that is AI, right? What is this black box of ours?
Yeah. Yeah, I think it's fascinating. I think people are, it's the terrible thing. It's taking jobs away. It's like, I mean, visual effects has always taken.
Oh, visual effects. We are
always.
I think we've got it's the worst for us that it's ever been, because it's really got commoditized, right? But I really get inspired by things like Godzilla -0, because you can see what a tight-knit crew of people, where the director, everybody knows what they're doing, how efficient they can be, right? I think as we move towards that world, a lot of the things that are hard to, the barrier to entry to filmmaking used to be so terribly expensive. You used to have millions of dollars worth of equipment just to even think about making a movie. And now, with this, you can do some incredible things. It blows my mind. The kid in me that wished he could, have extra film in his 60 millimeter Bolex camera, or, you know, these other things are just like what we have at our fingertips now is incredible. The industry is going to change though, and it's going to change dynamically. And I think it's just going to be less. There'll be less people needed that can wield these larger computers, you know, vision and machine learning algorithms that can do.
I think there'll be less people per project, but there's going to be a lot more
projects. Right. But what I'm saying is,
so in the end, it'll actually be probably more people.
Right. Well, yeah, that's the thing about visual effects is it never really seems to get smaller. It just, you know, it just seems to be spread out differently, distributed differently, you know.
Sure.
But projects are, achieving a photorealistic, you know, renderer where your perception of reality is completely and utterly, there's no difference between what you're seeing, you know, from a render versus from a camera, is been the goal for a while. We're very, very close to all of that. That's like, you know, for a multitude of things. And I think that as the machine vision stuff progresses, and as we see this neural rendering with machine vision rendering start to merge, that's when things are going to get really interesting.
What are your thoughts about real time now? Like, and how it's, you know, obviously we've always had real time to some extent, but what are your thoughts about how it's going and what it's going to become?
I mean, it is absolutely going to be real time ray tracing at some point, right? Where it's 100,
right.
For like what we've been doing at hundreds of frames per second, right? That's where it's going.
Right.
That's where it's all going. It's going really rapidly in that direction.
Yep.
You look at things like DLSS and all these other like sort of technologies that sort of speed things up. And that's where I think, you know, machine learning, once that neural rendering meets, you know, real-time rendering, I think that's when you're going to start to see some pretty amazing things happening.
Right.
We're having a hard time with compute, you know, because I think we've sort of reached Moore's law is not, we can't keep going because they can't make things smaller anymore. They've microdized all of it to the point of, now they just have to make them bigger. So you can see the CPUs are going, you know, the GPUs are getting.
It's funny, right? I mean, it's like it's a 4 nanometer chip, but it's like the size of a car battery.
Yeah. It's like you're welding all of these things together. It's like, we'll just weld.
I mean, this machine right here, it's got one CPU in it. Yeah. It's got 96 cores, but it's
crazy.
Right.
The amount of compute, you know, that's happening is.
Can you imagine if you and I like had a computer that had 96 cores back in the day? That is essentially like the entire farm in one
entire render farm,
one chip.
Right. It's like it's an insane amount of compute. Yet, right. You know, people get more ambitious and then throw more stuff at it, right? It's like, well, I can render 1 trillion trees. Let's try 2 trillion trees. You know what I mean? It's like,
yeah.
It's always, it's funny. It's like, what is the adage? It's like, rendering times never change. Like the thing.
That's called Blind's Law.
Yeah. Jim Blind.
It's called Blind's Law. You know that Jim Blinn taught one of the first computer graphics classes at the Art Center in Pasadena.
I do know this. I do know. And I've actually met Jim
and
Blinn.
So and my fly fishing mentor was a student there, and his first class in computer graphics was Jim Blinn.
That's incredible.
Yeah.
That's incredible. So do you know Carmi Wiswig?
I know the name.
So Carmi used to hang out with Wook all the time. He was like
with Wook,
Wook's sidekick forever. So
okay.
Carmi knows like all like the Ed Catmull and Bill Reeves and like all those like old school like ray tracing roundtable.
Those old hippies.
Yeah, the hippie roundtable ray tracing roundtable guys. SIGGRAPH, circa when it started,
Yeah. I ran into Jim Blinn a couple of years ago at SIGGRAPH, and he's like all the banners on him, just go down like his kneecaps.
He's like the general, like he's like the 4-star general of rendering.
Yep. It's pretty funny. Yeah, that's funny. I mean, yeah, it's just kind of interesting that's where it is. So what's going to happen now? Like, Global Objects, you guys are creating the data set, the 3D data set of training. It sounds like that's what you're
focused on, right?
First
we're going to start to offer some products for the visual effects and virtual production world. So we're creating these pre-baked sort of sets and props and stuff that are like ready to run in real time.
Oh, right.
Right. So, and we're gonna come out with an array of those, and then we're gonna have some some machine learning stuff and some other objects and things that you can get, and that'll be sort of the first product offering. That'll be like at the end of the year, probably around November, December, and then on our next, we're going for a Series A raise, and we really want to invest heavily into thinking about and pushing, the training set really hard and figuring out, what do we really need to do? Because like, I know I don't need to scan every donut in the world, right? I just need to scan enough donuts to be able to synthesize any donut, right? So,
right.
And it's that way with
what's the minimum viable donuts?
Minimal amount of donuts I need to capture to be able to make any donut I can think of, right? And there is an answer to that question. There is. And it's not as many as you think, right? So once you have the parameters of what a shoe is and how it works, but you got to start thinking about things procedurally. And that's where all these tools are going too. Like you'll notice like Blender's got procedurals and I was going to say prisms. Houdini's got procedurals, right? And Unreal's got procedurals. It's all building things out of components is probably the way to go, right? And then you have parameters of components, and then you can teach machines how to do that. And that's and that's probably where it's all gonna go for us at least. And then in terms of like the real time stuff, I see real time ray tracing coming very, very soon.
Right.
It's
almost. I mean, it is here. Yeah. I know it's here because I've been using it every day.
I mean, you're already using it, right? I've been playing with it. There's, we don't have to, if we don't have to cheat, why cheat? You know what I mean? It's like,
Well, that was the thing that Vlado first said. When we're looking at real time stuff, he's like, we know that real time is going to replace offline rendering, right? At some point. But one thing is for sure is rasterized rendering is never going to replace ray tracing. And ray tracing is always going to replace rasterized rendering.
Every time.
In terms of the accuracy.
Every time. Ray tracing is the right.
We've been through this in 2006.
We know this. The problem is it's like everybody's trying to, they want to cheat it, and they want to, and they're trying.
Well, that's what we were doing in 2006 because it's like, we don't want to ray trace. So we'll find as many cheats as possible to avoid ray tracing, when if you just ray traced it, you're done.
Right. And it makes it makes so much more sense. But, video games are starting to become aware of this, right? They're starting to be like, as the hardware is there and they can start dumping, more at these graphics cards and the GPUs, more is going to be, possible. I for one know that we just need to start upping the memory in these graphics cards. Like it's all memory based, and we just
how we use memory or the bus.
Be more efficient on the bus, or how can we distribute it? Can we have a shared memory architecture?
So they used to have that, and they took it away, which is interesting.
I know,
right? So they used to have NVLink, and they took it away, and they had all these different things, and I think it's interesting. But, if you're smart, and I don't want to, you can, listen, I got, like I said, trillions of polygons advantage with basically 12 gigs of memory.
Yeah.
It's very little memory considering.
It's so efficient. It's like, wow. Right. And you look at it and you just go, holy shit. Like this is, can I say holy shit?
That's okay.
I'm like, this is incredible, right? This is what you need. You need to be able to have that ability to be able to just throw anything at it it needs to be able to instance it all correctly. It needs to be able to partition the memory out correctly. It needs to be able to go through and because that's where all this stuff is going. It's just like everything all at once, right? Like that's
right.
That's where games are going. That's where these worlds are going. And so I believe the era of real-time ray tracing is upon us. I know that, especially you guys are taking your time, making sure that, it's all ready to go. And it's incredible though. Like it blows my mind how good it is already. You know what I mean? It's like,
yeah. And it's not just about the lighting. That's the thing that I think people when you start to really use it, it's not just about the lighting. It's about the efficiency. It's about like, once it's ray traced, then you don't have to worry about so many other little hacks that you've been doing.
Right. Like once it's ray traced, if you have a proper, physically based material workflow in a properly set up scene with proper ray tracing and light that's behaving physically the way that it's supposed to, right? That's where it all sort of comes into play.
Then you're done.
Right. You're you're simulating, right? Your simulation is there. It makes perfect sense.
I have this one example. I mean, I've been working at DD for a long time, and I love those guys, and I think they're amazing. And they did a bunch of digital human work, and I've done a bunch of digital human work. But I remember specifically on Oblivion, I'd always been a little like, it took so long to get to a good version 1 of their digital humans, right? Even though they were great, Benjamin Buttons was amazing, and there was interesting work on Tron, but it worked on Girl with a Dragon Tattoo.
Interesting work on Tron, I like that.
Well, yeah, because there was the challenges that they were focusing, but it was that little tweaky, right? And that's where the things get lost in the weeds when you're doing tweakies, right? And so when we worked on Oblivion, and there was a big sequence where there was Tom's fighting himself, spoiler alert, but we had to do a digital Tom, and I said, I was the lighting supervisor on it, and I said, you know what? Let me try to get a good version 1 by myself, because everyone else is too busy. That was the word I used. Everyone's too busy. I'm going to take a little time to do a version 1 of myself. We got Tom scanned at ICT. We know ICT data. It's very good, right?
Very robust.
Paul, very robust. Paul knows how to scan data. He knows how to calibrate cameras. He knows how to give you an accurate color, right?
That's right.
Not just him, but his whole team, right? And so I go there and got this data, and I get a version 1 of Tom, and here it is. And they're like, that's incredible. What did you do? I said, you know what I did? Nothing.
Right.
I used the data straight. And if you just use the data straight and accurately, and you understand physically based stuff, it should work.
Should work. I didn't have to do a bunch of other things. Right.
Nope. Defaults are actually really good.
Yeah, because they're there for a reason.
Yes, exactly right.
Tried and true.
Exactly right.
I was actually so Paul was at our 4th of July. I was talking about some of the problems that we've been having. He's like, "Oh yeah, I remember that."
Sure.
He's like, "I remember those problems," because everything that they're doing for the human face is essentially what we're trying to do for everything, basically.
Right. Yeah.
But you're right.
He's very good. Actually, that's one of the things I learned from Paul is he keeps things as clean as possible.
Yes.
He doesn't actually try to overcomplicate things. He just keeps it as clean as possible. That's what's brilliant about what he does. And he can explain it to your grandmother and she'll get it.
She'll totally get it. And he's very good. And color is very important. Color science is very important, and maintaining a consistency throughout the pipeline is very important.
Yeah. That's really, really, really cool. So yeah, I absolutely believe you. I mean, I think this is going to be, if you get good data, you get good stuff.
The old adage, garbage in, garbage out, good data in, great stuff out,
Yeah. As long as you don't screw with the data, then you're
fine. Don't touch it. Don't just leave it.
Don't touch it. Yeah, exactly. Well, this is really cool. So let's talk a little bit about your thoughts on virtual production and where that's going in the film industry. You were obviously mentioned you were goofing around on set as a kid, working on Who's the Boss or whatever show you were doing.
I was in a bunch of just a ton of stuff, like because it was you could get out of going to school, right? They had school, but it was really not much going on there, right? So it was really fun.
Right.
And you make some money for college, it was like super easy. So I loved it. I just loved filmmaking. When I was 6 years old when I saw Star Wars at the Uptown Theater. I think we were living in Washington D.C. at the time. Yeah,
you and I have similar birthdays. Yep.
Yeah,
I was same age.
It changed my life. I was like, I want to do this. This is what I want to do. I want to make film that makes people. That's been, it's been the goal. So, and I love movies. I love the set. And virtual production is really interesting. It's incredibly complicated, but it's getting easier. Meaning that, and it's back to what you were saying. Like there's so. You have to wrangle these real-time renderers, right? And they're so difficult right now. Because they're made for games, right? They're game engines. They're made for games, right? And so they're made to, it's your tool set for doing the things that you need to do is an afterthought. It really is. It's an afterthought. And so you're always fighting that, right? You're dealing with screens that were made for concerts and a video game engine that's made for games, and that's your tool set, right? So it's really in its infancy. It's starting to mature, and and sometimes it's gotten a little bit of a bad rap, and sometimes it's been heralded, and I think it's a new industry, but I think it's the way that things are going to be happening. You're going to see a lot more synthetic screens. I think we're going to see screens in our homes, right? I think we're going to have walls that are just going to be, and we'll be tracking our eyes, and we'll get parallax and stuff that way. I mean, that is the future of where things are going. But in the film industry, when you're doing virtual production right, and to get there's so much work that gets you up to that being on the wall, and there's this bar of geniuses that are like trying to make sure everything works. As soon as that all goes away, and it's just like a couple of guys that are like, and it's like you treat it like anything else on a set. It's the cinematographer should change the lights on the backdrop, right? The props guy should have a say in the props. The production designer should keep all that together. Like as soon as it gets more like that, it's going to be, everybody's going to be using it. Right now
props. There's digital props, digital grips, digital gaffers.
A gaffer should be a gaffer, whether it's digital or not digital, and typically, VFX people, we have to be the smartest guys in the room because we got to know how to simulate what you're doing. So we need to understand all of the problems, right?
Yes.
And I tell this to everybody. Yes. It's like production is fast and furious, and visual effects is slow and tedious. And when you crash those worlds together, it's tough because production is so intensely expensive and it's going so hot, and you need to run fast, and so. We're just learning to get our footing with how these worlds interact with each other.
Yeah, you can't be on set and have everything going and have some guy go, well, hold on, just give me a couple hours, I'll fix the set.
Yeah.
The digital set for you.
No.
That's not going to happen.
No. Nope. Cameron will throw his iPad at you. It's
like a ninja star.
Not going to happen. No.
Yep. Yeah. No, you got to be nimble. It's got to be quick.
Yeah.
Yeah. I mean, that was interesting, on this show that we've been doing, this short we're working on. That was the one thing that people told us was, it's like, of all the things, about the lighting center, one thing that was the most impressive about using Project Arena was that we used it for 3 days straight and it never crashed.
That's unheard of. That's unheard of, by the way. Like
yeah, they budget for 2 to 3 crashes a day.
No, yeah, at least, right? Like I could.
Right, and it's like 20 to 30 minutes to get back up again, right?
Oh yeah, especially when you're on a bigger stage and you have to like sync to multiple, workstations, and you're running a complex setup with end display. It can be highly complicated.
Yeah. Yeah, we never crashed. It was just like, well, just
that's amazing.
Load it up, ready to go.
Stuff looks really good too. Like you sent me some preview stuff. I was like, oh,
yeah.
impressive.
I was like, yeah, we had this train sequence which is in there, and we're just on the train. It's just going by all day long.
It looks so good. Like driving.
I kind of forgot that I was not on a train. I forgot I was on a set because the environment was just moving by me the whole time.
It feels real, right? Well, like process shots and all that stuff are going to change. The way that all that stuff happens is definitely changing. Environments, all of that stuff, especially when you can, put the, instance geometry and procedural generated terrains, and it's going to be it's already a game changer, but it's going to definitely be a game changer, especially in virtual production.
Awesome. Okay, well, if people want to know more about Global Objects, where can they go? What's the best place to find out more about what you guys do?
globalobjects.com.
Okay.
Hey.
Awesome. There you go.
Yeah, no,
Love
and contact us. We're in the middle of we're looking for some really good beta testers. We want to start to get some feedback on what we're doing, what we're building. So we're very interested in getting as much of that feedback as possible. That's going to be really important to us.
Right.
And we want to make it so that it's assets are easy and predictable and photorealistic. That's the goal.
Right. Awesome. Well, cool. Well, thank you so much, Eric. I know that you and I are going to be in touch because we're already talking about all kinds of projects to work together. So we'll do that. But it was awesome having you on. And then when we have more news from us, let us know, and we'll have you back on the podcast.
You bet. Thank you so much, Chris.